Okay. So before this, I will mention something about the versions of our slides. Actually, each time we have the class, we will update the slides a little bit. Actually, most parts of the slides are remain the same. Only small typos are fixed. If those are fine, if those are found during our when we learn this class. So the key difference in this, we typically add something here, right? So this is the key difference, right? I think. So if you have time, you can check our Tsinghua Web Learning after each class, and you may download the latest slides if you want. Typically, the slides are similar. Okay. I think time is up. We can have a 5 minutes break. After that, we will have a small quiz, a small in-class quiz. So please be prepared for that after 5 minutes break. Okay, thank you. Okay, let's continue our class. So before class, we will have a small quiz with only a few examples, very few questions actually. So this first question is a single choice question. What is the correct output of the program? So the program, it looks like this. Here's a base class, C base, and there's some public member print class, which prints base, and there's a virtual function print name, which print C base, and then there's a do print function, which calls print class and print name, and then there is a child C child, which is a child class of C base. And then in child class, print class and print name are overridden with outputs child and C child. Then there's a general function do print, which takes base pointer, C base pointer, and calls the base do print. Then in main, we have we construct a child object, and then we call do print. Then we delete the child. So these are the four choice. One is base C base, another one is base C child, third one is child C base, and fourth one is child C child. Okay, time is up. Let's check the results. So you can see here, most students get correct answer. Some students do not actually. So correct answer is B. Correct answer is B. Because this do print, we'll call this base pointer and then do print, right? There's a base class do print interface. So in this do print, we actually in class we mentioned that even in general function, when it calls virtual functions, polymorphism still works, right? So in this case, print class we will call child. This case child because print class is not virtual, so it will call the base version print class. So it first prints base, right? Then print name is a virtual function, so polymorphism works here, and so another the second one will be C child. Right? So this is correct answer is B. Okay. Next one. So this is a multiple choice problem. Which of the following descriptions is correct? Actually, it should be which of the following descriptions are correct, because this is multiple choice question. So first one is constructors can be virtual. Second one is destructors can be virtual. Third one is when calling a virtual function in a destructor, polymorphism does not work. Fourth one is when calling virtual function in a constructor, polymorphism does not work. I think this is not difficult question, right? Okay, time is up. We can see oh, only a few students, right? 38% of the students make the correct answers. So for A, constructors can be virtual. That's not possible, right? We have this slides. We know that it's not possible. And B, C, D are all correct. So that means when we call virtual function in the destructor, only the local version of the function will be called. Local version. Polymorphism will not work. Okay. Okay, next question. This is also a multiple choice question. Which line will cause compiling error or compilation error? So we have a class A. There's some virtual function f1, which is const. Virtual function f2, and also general member function f3. Then we have derived class B. So for F1, we overwrite this one, and then we define it as final, right, F1. Then for F2, we add the override keyword here. F3, we also add override keyword here. And then for derived class C, we define in this format. We also have an override here and here. So which of the following lines will cause compiling errors? Compiling error. Okay, let's check the results. You can see that more than half of the students get the correct answer. Correct answer is BCD. So for B, for A is correct. Okay, A is no problem, and because it's exactly the same version with this one in A, F2. F3 cause error because this F3 in A, this is not virtual, right? Not virtual function. So override keyword will not work, right? Will cause compiling error, right? Because this is override is for polymorphism, right? So this is not virtual, so this F3 will cause compiling errors. Then for this F1, because in class B, this is already final, right? It's already final. So in this one, in this number 3 statement, this override or this overridden of this F1 function causes compiling error because this is final, cannot be overridden anymore. And then for this one, F2, this one, sorry, let me check. So this F2 takes an integer parameter right here. So there's no such a function in the base classes. So this is cause compiling error. Okay, so these are the questions. Okay, now we come back to the classes. So now we'll learn some new design patterns. Factory method, abstract factory, and observer. We will also learn one new design principle, the single responsibility in design principle. So I will learn this singleton design pattern, which guarantees that there is a unique instance for a given class. And we also have just learned this design pattern adapter, so which consists of 2 types. One is object adapter, which adapt the adaptee into the member as a member by composition. We also learned the class adapter, right, in last class with the example viewer system. And then we learned the simple factory. Actually in simple factory, we still have some program to interface for this product. And this is program to interface. However, we have one question. So we have one question on this. Does this simple factory comply with open close principle or not? So from this class diagram, we can see that it is no, because when we want to add one new type of pizza or one new type of product, concrete product, we have to modify this function, right? We have to modify this function. We have to change the switch case and check whether we want to create this this product, right? So this part will be modified. Right? This part will be modified. So it violates the closed principle. Existing code should not be modified. We just increase our code by adding new code. We do not modify old code. So this is open close principle, open for extension, right? So this is the simple factory class diagram. So for example, if we want to add a new type pepperoni pizza, so we have to modify this, and we have to modify this. This violates the closed principle, right? Violates the closed principle. So how to do that? How to do that? Actually, in the Bible of design pattern book, in that textbook by the Gang of 4, simple factory is not a design pattern. We'll talk about this later. So simple factory, sometimes it is useful. We'll talk about this later, especially when the simple factory is combined with factory method, when it is combined with factor method, it is useful. So simple factory actually in some books are not design pattern. It is not a design pattern actually. We learn this because it has something related to program to an interface, and it is a good example to demonstrate that simple factory to demonstrate that the open close principle, right? So simple factory actually violates the open close principle. Okay, now we learn this factory method. It is also a creational pattern, which is for creating objects. So the problem is, in simple factory, does not comply with the open close principle because the reason is that there's only one factory for all type of pizza. Only one factory, right? Now the solution for factory method is to give a one-to-one correspondence between the factory and the pizza. So for a new type of pizza, we just add a new pizza factory along with the new type of pizza. We do not modify the factory. We just add a new pizza factory. Okay, so this is a solution in factory method to avoid this closed principle, to avoid the violation of the closed principle. This is factory method. This is a class diagram, a little complicated, of this factory method. So we can see that there are two class hierarchy in the class diagram. One is a pizza hierarchy. We have different type of pizza, veggie pizza, cheese pizza, pepperoni pizza, and we have a class diagram or class hierarchy of pizza factory. So this is the interface class, pizza factory, and we have veggie pizza factory, cheese pizza factory, and the pepperoni pizza factory. And each factory corresponds to a concrete product. Each factory corresponds to a concrete product. So whenever we want to add a new type of pizza, we just add a new type of pizza factory. Then we do not need to modify old code. So this is factory method. This is factory method. So in the pizza store, we only use pizza pointer and the pizza factory pointer. So this is program to interface because these two classes are interface classes, right? So in pizza store, we only need to access pizza pointer and pizza factory pointer. So whenever we want to add a new type of pizza, this pizza store does not change. It keeps unchanged, right? Okay, then this is a pizza factory. This is a factory method. And this is the source code of the factory method. So this is interface class pizza. And this is a pizza factory interface class. And these are the concrete classes for pizza factory. So we can see here, the cheese pizza factory, we implement this create pizza, override this create pizza interface. And in this create pizza interface, we return a pizza pointer. We return a pizza pointer like this. So be careful about this. We are always programmed to interface as much as possible. This is a key. This is a key. We always program to an interface as much as possible. Okay. And then in this veggie pizza factory, we again return the pizza pointer. And then in pizza store, we pass in the pizza factory pointer and then return the pizza. So in pizza store, program to an interface, right? This is the interface class, and this is the interface class. In this case, if we want to add a new pizza, new type of pizza, we do not need to modify this pizza store because it's only programmed to interface. Then in the main function, we have this pizza store, and then we create a pizza factory, cheese pizza factory, and then we can order pizza from pizza store. If we want to order different type of pizza, we just create different factories. Then we order the pizza. Okay. This is an example. We have the source code in C++ language, but I think this is not difficult to understand. So due to the time limit, we will upload the source code for you to check. We will not check it in class, okay? Then if we want to add a new type of pizza, Hawaiian pizza, for example, then again, sorry. So this is Hawaiian pizza, and then for the pizza factory, again, program to interface, return the pizza pointer. And then we can see that open-close principle is obeyed, right? Open-close principle is observed. However, we can see that for each new type of pizza, we need to add 2 new classes, right? This is a problem. So this is we will mention about this problem later. So this is a factory method design pattern. Actually, typically there are different concrete classes, different concrete creators, and different concrete products. And each creator creates its corresponding product. Okay, so for factory method, we are always programming to an interface. We're always programming to an interface. The interface class is pizza and pizza factory. And for concrete classes or implementation classes, there are cheese pizza factory, Wagyu pizza factory, like that. And pizza store is a user class actually, and it does not need to. Also programmed to interface, right? So if we add a new type of pizza, it does not need to be modified. So open-close principle is observed. We do not need to modify existing code. Also, for each new type of pizza, actually we add a new class for that, right? So what we are doing is to partition different tasks and assign them to different objects. So this actually obeys the single responsibility principle. So we separate the pizza creation tasks and then assign those different pizza creation tasks to different objects, right? To different pizza factories. So this is single responsibility principle. Okay. So typically, just like mentioned before, is partition different tasks and assign them to different objects. When a class has multiple tasks, we need to create a family of classes instead of single class. So be careful about that. In previous classes, we mentioned about this. We called it top-down design, right? Top-down style design. Style programming with BFS search, right? BFS search. So that means, so if we want to write one function, first write some lines of code, then we find, okay, then this part is very complicated. We cannot write it in this function. So we may write another function here, and then we write the following part. And then after a few lines of code, we find that another complicated task appears. Then we assign it to another function. Then write the remaining part. Then we finish this function. After finishing this function f, then we go into this one, f1. Then for f1, we write some code, and then f3, we find this also a complicated work, and then write some code, and then finish f1, right? Finish f1. And then for f2, similarly, maybe for f2, we only have some very small code before we finished. So actually, what we are doing for this function, after we finish the f2, the whole function is finished, right? So actually, what we are doing is that for f, we have some code, and then f1, then we have some code, then f2, then some code, right? Then after that, we come to this f1, right? Some code, then f3, then some code. Actually, I mentioned about this BFS, so actually this is not very exact, right? So if you are careful about this, you should maybe some students still do not know what is BFS, what BFS is. Actually, this is traversal of a tree or a graph. So actually, if in this case, if F3 have some complicated code, we will go deeper into F3, right? This is typical choice, right? Into this and this and this, right? And then come back after F3 is finished. Then we will come back to this, right? Come back to this F2, and then finish F2, right? So actually, this is I think more like depth first search, right? Depth first search. However, still not exactly the same. Sorry. Actually, this is a first order. Actually, this if you learn this, I'm not sure if you have learned this or not. I think this is pre-order, right? Traversal, right? Pre-order traversal. Traversal. 就是前序便利啊，不知道大家是不是应该有同学知道这个哈，前序便利啊，这个其实应该算是前序便利，而不是广度优先，对吧？ 就我们其实是从根开始啊，从根开始，先是把这一块写完，把这一层写完，然后呢就开始找它的左子，对吧？把这一块把这个左子呢这部分又写完，然后又开始找它的左子，对吧？这样下来，所以应该是先根顺序，对吧？应该是先根顺序的一个 traversal 啊。So this actually is not BFS. It is pre-order traversal actually. Anyways, if you have not learned this, you just know this idea is okay. The idea is you first finish this function. Although this part is not finished, this part is not finished, don't worry, right? Just finish this function first, and then go into this function and finish this function first, and then go into this function and finish this function first. And then you go back to this F2 and finish this function. So this is the key idea, right? So this is for function. However, for classes, we still have this problem. So sometimes if we look at others' code, we found that in a class, there's very long list of members and long list of data member and also function members, very long, right? So I don't think this is a good design, because if you have a very long list of members, probably this task can be partitioned into different classes, right? For example, if there are 30 member data, 30 member variables, maybe probably you have 10 variables that can combine another class. Right? You can partition these 10 variables with certain members and member functions into the new class, right? So this is single responsibility principle actually. However, you have to be careful. We are the one who are responsible for the granularity of the single responsibility, right? So the granularity, I think, is that similar to the function, the length of the function, right? For the length of function, we know that maybe 30 lines of code is enough for the function body. So for classes, we also should for each part of the class, for example, for the class body, for the definition of the class, including the members, member data, and member functions, maybe 30 lines should be enough. And then for the function bodies, also 30 lines. So this is single responsibility principle. We have to try to partition the task into different classes. This is one example actually. So if we want to do very good design for software, for example, we have to use UML actually. We have to use UML to first design all the classes, right? And then find the relationship between the classes and design it. Design all the classes that needed for finish this software. Okay. So in the head first design pattern, if you read the book, you may be more familiar with how to design a product, right? Using this UML, right? Okay, then this is a single responsibility principle. Next is a parameterized factory method. So some students asked, why simple factory? Why should we use simple factory, right? So that is because we mentioned that for this factory method, if we want to add a new type of pizza, we have to add 2 new classes, right? One is for the product, and another is for the factory. So if there are for example, 30 new classes, then we have to write 60 classes if we want to add 30 new products, right? So that's the number of classes increase dramatically. So one solution is to use the parameterized factor method. Originally, for the factor method, we use this, right? So in this factor method, we do not have parameters. However, we know that for simple factory, there are parameters, right? Parameters are used to determine the types of the pizza, right? Now we, for the pizza factory, for the factor method, we again add the parameters, Then, for example, if in the original design, we have a 30 type of pizza, then we can write it in this, right? We have 30 type of pizza. We can write it into this single function, right? So in this case, we do not need 60 classes for the 30 type of pizza. We just need one factory for the 30 type of pizza. However, so this avoids a dramatic increase in the number of classes, right? However, if you want to add a new type of pizza in the future, I mean, at the beginning we know that okay, in our store we sell 30 type of pizza, so our software is designed like that. Then after 1 month or after half a year, we notice that we need to add one type of new pizza, right? Then we can add another factory. For this +1. So for this new type of pizza, we can add another pizza factory. We do not modify the old code. We add a new pizza factory for this new type of pizza. Am I clear? So in this case, in the initial design, we can consider all the products. Then in the future, if we want to extend it, we extend it. We add a new factory. Okay, we do not modify old code. Okay, so this is parameterized factor method. It comply with the open-close principle, right? Because we still add a new factory for new type of pizza in the future. Okay. Any questions? Okay, then so that's the reason why we introduce simple factory, because the combination of simple factory and the factory method gets the parameterized factory method that is also useful for certain designs with many different types of pizza or products at the beginning. Okay, so parameterized factory method is a simple factory plus factory method. Okay, then we will come to a new type of design pattern, abstract factory. So abstract factory is also a creational pattern. The problem is that, for example, in the pizza store, originally it sells pizza. Now it wants to sell hamburger. Originally, we have the cheese pizza and veggie pizza. Now we can have cheeseburger and veggie burger. So we have several series of food, right? Several series of different flavors, right? Cheese and veggie. For cheese theory, we can have cheese pizza and cheeseburger. For veggie theory, we can have veggie pizza and veggie burger. And we can also have Hawaiian theories like that. So this is for a series of products. So how to create a series of products? This is a question, or this is a problem. For the series of products, actually we use abstract pattern, abstract factory. Another example is a factory for creating database users and administrators. For database, actually we will learn the database in the future. We have database classes. Basically, database is software for storing. We all know the big data, right? Database is to store those big data, right? It's software for storing the data and inquiry the data, modify the data like that. So there are different products from different companies. From Windows, a Microsoft company, and there's a SQL Server database. And also, there's Oracle company with Oracle database, a MongoDB company with MongoDB database. Actually, although these different products have different implementation mechanisms, and their interfaces are similar. That's why we have different series of the databases. Okay. Okay, then that's all for today's class. Thanks very much. Goodbye. Okay, let's start our class. So in our last class, we have learned the factory method. Now we are learning this abstract factory. So abstract factory is used to create a series of products, For example, in the pizza store, originally they sell cheese pizza, veggie pizza, things like that. That is cheese theory. And now we want to sell the. Now we want to the cheese theory and veggie theory. Originally we have the pizza, veggie pizza and cheese pizza. Now we want to sell this burger. Right? So we already have the series, so we can just add the burger, right? Cheeseburger and veggie burger like that. And another example in the database. So in our last class, we have learned that, for the database, there are different companies who have those products and those software. So actually, for the different companies, although the software are from different companies, they always have the database users and the administrators, things like that. Okay. So abstract factories can be used to create such theories. For example, SQL Server theory, Oracle theory, and MongoDB theory. Right? So abstract class can be used to create families or series of such related products or objects. So this is the abstract factory class diagram or inheritance diagram. From the diagram, we can see that originally for factory method, we know that for each product, we have a factory, right? So each factory corresponds to one product, right? So whenever we want to add a new product, we add a new factory. Now in abstract factory, each factory, this is the interface, right? This is the interface, and this is a factory, concrete factory. So each factory corresponds to a series of products, This is a theory, This is a theory, and this is another theory, So theory 1 and theory 2. So each factory corresponds to a series of products. Coming back to our pizza store example. So in this example, the factory is cheese factory and the veggie factory, or salmon factory, like that. So cheese theory, veggie theory, like that. Someone may argue, why should we design like that? Why not design like each concrete factory correspond to an inheritance family, like this? Why not for each concrete factory creates a family of products? That seems easier, right? So whenever you have a new product, you just create a family of inheritance for the product, and then you can add a new factory. Why not design like that? This is not possible. You can try to design like that, but this is not possible. Okay, so if you're careful, be careful about that. So if you want to design like that, you need to modify this, right? And also this. This inheritance family, this inheritance diagram of the factory is not possible to design. You may try it. I think you will fail because I already tried it. It's not possible. Okay, so this is abstract factory. So each concrete factory corresponds to a series of products. So here is the theory 1, and here is the theory 2. Right? So this is the class hierarchy. Okay. So coming back to our pizza store example, you can see that this is the veggie factory, corresponds to the veggie theory, and the cheese factory corresponds to the cheese theory. Okay. So here is the source code of the abstract factory. So first we have the okay. So first we have the base class or interface class of the factory, which creates both pizza and burger. You can see here we are still programming to interface, right? These are interface. So these are interface base class. And also for the cheese factory, this is the design of the cheese factory. We can program to interface and create a pizza. Because we are in the cheese factory, we are creating cheese pizza and cheeseburger, right? And program to interface. And then for Wagyu factory, we create Wagyu pizza and Wagyu burger. These are different, and this part is the same, still program to interface. And then at pizza store, we can order pizza and order burger, but they are programmed to interface like this. This is also interface, PP factory. These are interface. So in the future, if we want to add a new theory of product, salmon flavor or other Hawaiian flavor like that, we just do not need to modify this part, right? Because this is program to interface. These are base classes. We do not need to modify it. So this is the merits of program to interface. Okay. And then for burger is actually similar to the pizza, design. Then for the user program, we can create a factory, and then we can order the corresponding flavors of the products. For cheese pizza and cheeseburger, we can use this, and so for veggie pizza and veggie burger, we can use a veggie factory, right? Veggie factory. So in the future, if we want to add a new flavor, it's very easy to design that, right? We just add the corresponding concrete products, right, in the different inheritance family. Okay, then this is the abstract factory pattern. It provides an interface for creating a families or series of related or independent objects without specifying objects' concrete classes. We do not need to specify the object concrete class because we program the interface, right? And we just need to provide the factory, right? The factory. So we program to an interface, the abstract factory, abstract product, like that. So we can obey or observe the open-close principle. Open for adding new families of products, or actually new series or new families of products, and close for modifying existing code. We are also observing the single responsibility principle. So each factory is corresponding or responsible for creating one family of products or one series products. So this single responsibility principle actually is related to decoupling. Decoupling between different functions, right? Different functionalities. So this is also actually also a design principle. We should always decouple between different parts of the code, different functionality, and also we need to decouple. For example, we need to decouple those change during time and those does not change, right? We already did that in previous examples for sell pizza and manufacture pizza. So those two functions should be decoupled, right? We decouple between them. Then whenever we need to create a new pizza, we just modify the corresponding part. We do not need to modify sell pizza, right? Like that. So the single responsibility principle actually related to decoupling different tasks. Okay, so but we won't learn so many design principles because those are related to each other, and I think the most important ones are these. Whenever we remember or we memorize or we memorize to program to interfaces, then our design should be kind of good, and it kind of observe open-close principle, and also if we can do the partitioning of the tasks, and then single responsibility principle will be observed, and probably and the decoupling between tasks are also performed by this. Okay, this is the OP design principle. Another example of the abstract factory. Here we want to design a toolkit for the look and feel standards. For example, we all know that in Windows and in Linux, we have the different look and feel. for the different widgets, different windows and buttons, very different look and feel, right? So how to make this design easier? For example, our original design, this design actually is not good. It's like this. We have widget factory. So this factory creates windows and scrolls based on the parameter style. We can give it Windows style, Linux style, Mac style, like that. Then this also programs to some extent, it programmed to an interface, right? So because we have different windows, so this is actually a base class, right? So we are programmed to interface. So this factory can create different look and feel windows and scrolls. However, we have a switch case here, right? Switch case. So if in the future we want to add a new style, then we have to modify this part, right? This part needs to be modified. So this violates open-close principle, right? Violates open-close principle. To violates this principle, right? So for the Linux factory, for example, this is a this Linux factory can create the Linux windows and Linux scrolls. And then for Windows factory, we can create corresponding ones, right? So this is another design. We use abstract factory to do this. Using abstract factory, we can create different series like this. So using abstract factory, it should be better, right? If in the future we want to add a new theory, we just add a new factory, right? Add a new factory. So this old code does not need to be changed, right? So this obeys observe the open-close principle, right? For example, if we want to add a new Mac style, a Mac look and feel, we just add a Mac factory, right? Mac factory. And we can add the Mac window and the Mac window, Mac scroll in the class hierarchy of the window and scrolls. Then we only need to add a new code, right? We do not need to modify old code. However, in the previous example here, if we add a new style, a new code, a Mac window, for example, we need to modify this. We need to add code here, right? We need to modify the code, right? However, but if we use abstract factory, we do not need to modify the code, right? It's like this. We use the factory, we just create corresponding window and scroll. I do not need to modify any existing code. Am I clear? Okay. So abstract factory, using this abstract factory, we can obey or observe the open-close principle, right? Then we come to the next one, observer. The observer design pattern is also called publish subscribe pattern or source listener pattern. So it has many-to-many correspondence. For example, we are all using WeChat now, right? So there are some public accounts or official accounts, 就是公众号啊 ，public public accounts. So we can subscribe the public accounts. Then we can read their articles, right? On WeChat, right? So that is subscribe, right? We are subscribers. And each one of us can subscribe many different public accounts. So we can read different articles from different sources, right? So that is many-to-many. And each public accounts has many listeners or subscribers. So this many-to-many correspondence. And when the subject changes the status, it will notify all the observers. When the public accounts change their articles or write new articles, they will publish, right? Then all of us can read the code, read the articles, right? So this is the design, how we design this publish, subscribe pattern. So we have a subscriber, and we have a publisher. Then each publisher has a list of subscribers. So be careful about this. Here, for subscribers, this class, we have done a forward declaration. Declaration. 前项声明啊。So we have done a forward declaration because otherwise there's no way to design like this. Oh, sorry. There's ways. You can for example, you can just write this class inside this header file, and then you have the class here. Then you can declare it in this way, right? So this an easier way or convenient way. You just declare this class here. You do not need to add other header files, so that you do not need to add the declaration or definition of this class, right? So because you have declared the subscriber class, so you can declare a list of pointers to the subscribers. However, if you want to declare a list, a list of subscriber objects, this will be yes. This is not possible, right? In this case, you have to provide the class definition here, right? Before we define a list of objects. So sometimes there are cases if we design a class A, in the class A's body we use class B, right? And then when we design class B, in the class B's body we use class A. So in this case, this is not possible, right? This is not possible to design like that, because if we want to use class B, we have to have the class B's definition before class A. Then if we want to use class A, we have to have the class A's body or definition before class B. So that is conflicts, right? Conflicts. So in this case, we have to use pointers. And then we have to declare class B before we use it. The structure is virtual. These are base classes, right? Why not be virtual? So I think the virtual is safer, right? It's safe. We have learned this before. Whenever we want to have a virtual or inheritance class or some base class and derived classes to avoid memory leaks, right? To avoid memory leaks, we have to declare the destructor as virtual, right? We have learned this before, right? So it is much safe. If you want to have a class hierarchy, we are suggested to use virtual for the destructor in case there may be some memory leaks. Okay. So coming back to this problem, this is forward declaration, right? We use this forward declaration to avoid this conflict. Otherwise, there's no way to resolve this conflict between the two classes, right? So this is forward declaration. Okay. This is publisher, and then detach. Detach is to find subscriber and erase subscriber, right? And notify, when the publisher changes status, it will update all the subscribers. So this is actually a callback, right? Callback function, use the subscribers update function to call back. And then this publisher is passed to the subscriber so that the subscriber can get whatever the subscriber wants to get article, for example. Then the subscriber is designed like this. So the major or key function is the update. We get anything we want from the from this update function. Then we have a newspaper. So publisher is base class. So the destructor is virtual. So that there may be some memory leaks if the destructor is not virtual. Right? And we have that example in our previous slides. Then for newspaper, there are some member functions for this news. And for the magazine, it's also a publisher's derived class. And then for the reader, the update function of the reader, we can get what we want. Get what we want. So from this design, we can see that actually the publisher does not need to know details of the subscriber, right? You can see here in the publisher, sorry. So in the publisher design, we only know that there are some subscribers, and this also program to interface. We only have the base pointers, right? Base pointers of the subscribers. We do not need to know any detail of the subscriber. We only know that each subscriber has an update function, right? We only know that, only know this in the publisher. So this decouple between subscriber and the publisher, right? So you can design your subscriber as you want without affecting publisher. So publisher only calls the update function, and it's fine, right? And this is how we use it. So we design objects, define objects, and then attach and notify, detach and notify, like that. Okay. And this is the class diagram. We have the publisher base class. So to emphasize this again, if you have a class hierarchy, inheritance of the classes, the destructor of the base class is suggested to be virtual. Okay. So virtual destructor. This is suggested. Okay. And for each publisher, there's one to many correspond composition. We can have a list of subscribers. And then in the reader class, we can get the magazine, get the newspaper. So publisher does not need to know details of the subscriber. However, subscriber knows some detail of the publisher, right? So that we can get magazine content, right? And newspaper content, right? This is the official design pattern or official class diagram, similar to that one. Right? So we have an observer. This is subscriber. We have update function, and then for the publisher, we have attach, detach, notify, and then it calls subscribers update function to notify. Okay. So using the observer design pattern, when the subject is changed, all observer objects will be updated simultaneously. And the number of observer objects can be dynamically changed by attach, detach. And the subject only needs to notify observer objects and does not need to know details of observers. This is the key, right? We all know that, for example, for we are WeChat users, we are subscribers to the official accounts in WeChat. We do not need to expose our details, right? And there's no way for this design pattern to expose our details. Okay. Okay, then this is the abstract factory and the observer. So if you have time, you can do some optional exercise. This optional exercise is not required or mandatory. You can voluntarily finish this exercise, and in the at the end of the semester, we will open a link for this optional exercise submission. You can submit all your optional exercises throughout this semester. Submit it at the end of this semester, and this only counts for those who may have difficulty in passing this class. Okay, otherwise this does not count. 就是这些可选的作业啊，我们可以自己选择啊，要不要做啊？如果要做的话呢，就是说我们会在这个学期末呢给一个提交的这个链接，把所有的这个可选的作业呢，自己做的作业呢都提交上来啊。这个对于这个如果觉得这个通过这门课有难度的同学可能会有帮助，但是对于其他同学应该没有这个分数上的帮助啊。Okay, now let's learn something new.